So hey guys, I am Manasoma and I am going to present you a small presentation on noise cancellation. So first of all, I am going to tell you about some definition and history about it. So the definition is simply removing unwanted and irritating voice and sound from the background when you are listening, recording or talk to someone online or recorded your voice simply. Like about its history, in 1933, Paul Luke, a doctor of philosophy and medicine in Germany, submitted a patent application describing the principle of active noise cancellation. This is the very first time development of noise cancellation begins. So in present, there are many methods of noise cancellation present used to clear different type of signals. In this presentation, I am going to present you some methods for noise cancellation in sound that we can hear. So first of all, I am going to talk about simple types. It's like we can on the basis of real time or non-real time. So in the field of non-real time, there is a single type like during data pre-processing, and on real time there are three categories like active noise cancellation, passive noise cancellation, and adaptive noise cancellation. Now this adaptive noise cancellation is also divided into two categories like multi mic and a single mic. Single mic is normally use RNN. So basically the first type of noise cancellation you are going to see is passive noise cancellation. It's like when a device is capable of block out some amount of noise based on its physical structure or design of it has passive noise cancellation. So some of the examples that I have given in this presentation is like the first one, the headphone earbags or ear cups that is made from the foams. The second example is it's like dampers. It's used in the circuit where the vibration may be occurred. It's like drones. The third is like soundproof rooms where the foam coating on edges of a window or door can be put, or you can simply use three-layer glasses so the sound cannot reach out us from the glass even. And the fourth part is damper circuit. Damper circuit is used with a circuitry structure. So the second type of noise cancellation I am going to present is active noise cancellation. It is a method for reducing unwanted sound by adding of a second sound specifically designed to cancel the first. The signal from the sound mic is related to external noise, so it is inverted and add to the sound we want to listen. It's like there's some noise came from outside, and when we wear a headphone, the outside of a headphone have a mic which can capture the noise that is created outside and create a 180 phase shifted form of it, and it can create that noise of 180 phase shifted with the speakers. So when the 180 phase shifted wave and the noise came with each other in our ear, we hear no voice. The second example of active noise cancellation we can see is in our smartphone. Our smartphone normally have two microphones. One is below and other is upper part of our phone. So the upper part of phone there is a microphone named that is like secondary microphone. It is normally used for noise cancellation. So you can get that microphone on back side of a phone or upper side or side. So the third type of noise cancellation I am going to show is data pre-processing. So we normally pre-process all data before using machine learning models. Here is one of the method for noise removal from given data signal. We can eliminate noise on the basis of amplitude, threshold of frequency selection after taking Fourier transform. Below is an example of amplitude threshold. So it's like I'm taking a threshold of 375. So all the frequencies which have amplitude greater than 375 are to be allowed, and others are to be decreased to 0. So after taking inverse Fourier transform, we can get a signal like this. The second part of that type of data preprocessing is like a frequency elimination noise reduction. Whenever we know that we only want a particular type of frequencies to be used in our extra use, we normally take a filter like this. Here I take a Kessler filter. It's seen like this. So we take a Fourier transform of our signal, multiply it from Kessler filter. It's created a filtered Fourier transform. So these signal data after taking inverse Fourier transform of this filter Fourier transform can be used in feeding to a model for better learning operation, or even we can use this filtered Fourier transform also. And the last type that I'm going to show you is adaptive noise cancellation with 2 mic. Adaptive noise cancellation is a first category with 2 mics. On types of on the slide where I show the types, different types, I says that adaptive noise cancellation can be divided into 2 parts: multi mic and a single mic. Multi mic is too complex, so I take 2 mics, and it also includes computation. It's like this diagram. There's a 2 mics. One speaker is sitting. Our speaker is sitting near the mic Y1, and the noises are created all over it. Y2 only take the noise as an input, and Y1 take noise and speech both as input. Y2 is having a reference of noise signal. An adaptive filter is applied to Y2 and then subtracted from Y1 to generate En, which has less noise. And after that, En is feedback to the adaptive filter. Any adaptive filter algorithm can be used to determine the optimum filter, but a normalized least mean square is the most common used because it provides the best trade-off between convergence, speed, and computational complexity. So I have shown the algorithm that is used in this particular type of noise cancellation. It's like this is the filter. The optimal filter is reached when En becomes 0. Here mu is step size parameter. So when it is started, from starting, mu is bigger, but after some time, when mu is decreased with time, it start convergence and En becomes approximately 0. So after the En becomes approximately 0, our algorithm starts filtering noises from our data. The performance is just like this. It is an input signal and it is output signal. The second type of adaptive noise cancellation is a single mic, which includes R and N for better voice filtering. So what is R and N? R and N are very important here because they make it possible to model time sequence instead of just considering input and output frame independently. Like CNN, they considered input and output frames directly. RNN, so RNN, so we take RNN here. RNN can use in real-time processing. So in RNN we use GRU unit. A GRU unit has 2 extra gates. The first gate is reset gate and the second gate is update gate. Reset gate control whether the state is used in computing the new state, whereas update gate controls how much the state will change based on the new input. Here we use bark band that approximately contain 22 bands that make computation easier as it has low bands, and it makes it impossible to create so-called music or noise artifacts. So here I saw a structure of the model that we use in one mic adaptive noise cancellation. Because audio has huge dynamic range, it's much better to compute the log of energy rather than to feed the energy directly. So we decorrelate the features using DCT. DCT is more like DFT. DCT, the full form of DCT is discrete cosine transform. So discrete cosine transform is like a discrete Fourier transform but having only cosine part in it. So it's a take on the real part and output also real part. The result data is Kapstrom based on Bach scale. In addition to the Kapstel coefficient, we also include the first and second derivative of first 6 coefficient across frames. So it's like we have different frames. We have different frames, and there should be a derivative of it. Okay. On going from one frame to another frame. The second is pitch period. It is divided. It is approximately 1 upon frequency of fundamental. The third is pitch gain. The voice stand in 6 band. The fourth is spatial non-stationary value that's useful to detecting speech, but it is beyond our scope of this PPT, so I don't elaborate this part. That makes a total of 42 inputs, like 22 from this part, and 6 plus 6 12 from this part, 1 from this part, 6 from this part, and 1 from this part. It's completed 42. So our architecture is like this. Input feature of 42. It is feed to dance 24, then GRU 24 dance 1. It also put into GRU 48, that 48 output, and GRU 69 dance 22. And dance 24 is also put in GRU 48, and that GRU 24 is also put in GRU 48. It also put in GRU 96. So it's like complicated architecture that output of VAD output and gains output. So I have just show final. I put a video from YouTube by NVIDIA that uses real-time noise cancellation with help of AI architecture developed by NVIDIA only for a video conferencing. So it's like this.
Wow, that is a lot of noise that no one else needs to hear. Okay, that's better.
So it's a small video that you can see. Starting the noise was there, background in the background. The kids were playing, and after the filter is applied, there was no voice. Kids were playing, and there's no voice of kids when you are talking to somebody else. Last part is the other applications. There are many applications of noise cancellation. One of the cognitive radio is like we are using noise cancellation in a wireless connection like Bluetooth and Wi-Fi, etc. The second is filtering noise of different sensors using Fourier transform. The third one is noise reduction in image. The fourth one is damper user in drones for removal of noise for height calculation. Actually, I was working on drones, and the damper helps a lot of much for removing of errors on calculating heights. The last that I can find out is a night camera using which is use a larger exposure for reduction of noise. So this is references, and thank you.